Hello, my name is Elaine Kiconco and this is my presentation on cache memory. So cache memory is a small high-speed volatile memory which is positioned between the RAM and the CPU. The cache memory can access data at a much faster rate than the RAM since it contains a copy of portions of the main memory, which is the RAM. The primary purpose of the cache memory is to store recently or frequently accessed data and instructions, hence reducing the need to access the slower main memory and resulting in faster data access. Logical cache, also known as virtual cache, stores data using virtual addresses. And the logical cache access has a faster access speed than for a physical cache since it is placed before the MMU, and therefore the cache can respond before the AMMU carries out an address translation. Cache is in levels, that's level 1 to level 4. It has levels, and level 1 is the fastest out of all of them since it is located directly on the CPU. Though level 4 is much slower than level 1, they all together are still faster in accessing data than the RAM. Then this is the diagram of a typical cache organization. So here the cache connects to the processor via the data, control, and address lines, which all have an address buffer and data buffer respectively. These are also connected to our system bus, from which the main memory is reached. And so when the processor attempts to read a word from memory, a check is made to determine if the word is in the cache. And if the word is found, a cache hit is registered. However, if the word is not found, a cache miss is registered. Now, when a cache hit occurs, the data and address buffers are disabled and communication remains between the processor and the cache. Though when a cache miss occurs, that's if the word is not found in level 1 cache, the address is put back into the system bus and returned through the data buffer to both the cache and the processor. So it moves from level 1, checks through level 2 to level 3 continuously. Yes, that's the typical cache organization. So next we have a mapping function. Since there are fewer cache lines than main memory blocks, an algorithm is needed for mapping main memory blocks into the cache lines. The techniques are the direct mapping, associative mapping, and set associative mapping. Our first illustration here is for direct mapping, and the second one is for direct and associative mapping. Sorry, it's for associative mapping. So direct mapping is where each block of main memory is mapped into has only one possible cache line that it can be stored in. Yes. Then associative mapping permits each main memory block to be loaded into any line cache, which lowers the chance of multiple memory blocks competing for the same cache line. And compared to direct mapping, associative mapping is much friendlier than direct mapping. I don't know if I can say that. Yes. So aside from that, we have the set associative mapping, which is like a combination of both direct and associative mapping. And here the cache is divided into several sets, each containing multiple lines or slots, and each line can store a block of data from main memory. I think that's it for mapping functions. Next, we have replacement algorithms. So when a new block has to be brought into the cache and all the slots are full, one of the existing blocks must be replaced by a new block. However, for direct mapping, as we have seen on the previous slide, there's only one line for any particular block, and hence no choice is possible since each main memory has its own cache slot. However, and which is not the case for associative and set associative techniques. These require a replacement algorithm. So now the forms of replacement algorithms that we have the least recently used. And here, the block to be the block in the set that has been in the cache longest with no reference to it is replaced. And this has proven to be the most effective and popular method used. After we have the least frequently used method, where the block in the set that has experienced the fewest references is the one that is replaced. Then we have first in, first out. First in, first out, and here the block in the set that has been in the cache longest is replaced. The other one that we have that I didn't include in my slides is the random replacement policy. And here the block to be overwritten is chosen at random, hence emptying a slot for another block. So here there's random selection. Thank you. That's it for us.